Dear students, welcome to today's class. So today I am going to explain a very important chapter, that is relations. So last few classes I explained about the sets, various types of sets, definition of sets and the representation of sets, and we also did some problems which are very important for JEE mains examinations on the chapter sets. So after learning sets, now the next chapter is relations. After these relations, we will go for functions. If you want to know the all concepts of functions, you should be strong enough in the chapter relations. Now in today's class, I am going to explain what about ordered pair, Cartesian product of two sets, and what is a relation, and what is the domain and range of a relation, and what is inverse relation. So these are the 5 topics that I am going to discuss in this class. Okay, so let us start our class. Dear students, to make you understand about what is an ordered pair, let me give some example. First, there are 3 students are there. Their name is Ramu, Gopi and Shyam. Ramu, Gopi, Shyam. After their school, they went to the ground and they want to play any game, whatever they like. So that's why Ramu selected a cricket bat. He selected a cricket bat to play. And Gopi selected volleyball. He selected volleyball. And Shyam selected hockey stick to play the game. Okay, now the Ramu is related with the cricket bat. Then I can write it as a Ramu, cricket bat. Here Gopi is related to volleyball. That's why can I write down Gopi, volleyball. Volleyball. Here also Shyam is selected hockey stick. Hockey stick. That means by seeing this combination, that is Ramu cricket bat, Gopi volleyball, Shyam hockey sticks. What do you understand? This is a pair. First of all, pair. Pair means 2. Is it in one order? Yes, it is an order. Why? Here the first one is name of the person. The second one is whatever may be that. The second one is a instrument to play some game. Okay, so it is an instrument to play some game. That is a Ramu cricket bat. That means from that, what can we conclude? That means Ramu chosen cricket bat to play the game, right? Gopi chosen volleyball to play the game, and Shyam selected hockey stick to play the game. From this what? That formation, this structure, this in mathematical structure is called ordered pair. Understand? So if I write it as a can I write it as a ball, Ramu? Can I write it ball, Ramu? No, I cannot write. Why? Because here the first elements are name of the persons and the second elements are some instrument to play the game. Understand here? So ball, Ramu we cannot take it as. Why? Because the first element should be here. For in this structure, the first element should be the name of the person and the second thing should be the any instrument to play the game. That's why this is called ordered pair. Ordered pair. Pair means 2. This should be equal. Ramu, cricket is not equal to cricket, Ramu. Understand this? So that's why any pair of elements A and B which are written in a particular order, this is called ordered pair. So let me write the definition of ordered pair. Dear students, coming to the definition of ordered pair means a pair of elements A and B, any elements written in a particular order, say A comma B, is called an ordered pair. So these numbers, the first element and second element may be numbers, may be names of the persons, may be any symbols like that, x comma y may be symbols. Both belongs to same category or different category, that is a x comma 2 like that. Any two numbers or any two items or any two things written in a particular order in this formation, in this structure, in this mathematical structure, they are called ordered pair. Why you have to, so pair means 2, why you have to call it as ordered pair means, here x comma 2, x is called first element, and 2 is called second element. Here the position of the elements is a very important. X comma 2 cannot be equal to 2 comma x. Okay, na? But for a set it is equal. For example, set 1 comma 2 is same as set 2 comma 1. In the set, the order of the elements is not important. 1 comma 2 is same as 2 comma 1. Understand? But whereas in ordered pair, the position of the element is also important. Here x is in first place, but here x is in second place. Here 2 is in second place, but here in the second ordered pair it is in first place. Therefore, they are not equal. So in general, a comma b is not equal to b comma a unless a is not equal to b. If a is equal to b, then you can say a comma b is equal to b comma a when a is equal to b. When a and b are both are equal, then a comma b is equal to b comma a. Understand? Unless otherwise stated, in general a comma b is not equal to b comma a. Understand? I hope that you understand this concept. So let us go for next topic. Dear students, in the ordered pairs, now let us see some properties of the ordered pairs. Unless otherwise stated, in general, a comma b is not equal to b comma a. A comma b is not equal to b comma a. Second one is, if a comma b is equal to b comma a, thus implies and implied by a is equal to b. When a and b are both are equal, then only a comma b is equal to b comma a. The next one, very important, this topic is very important. When you say that two ordered pairs are equal, then x comma y is equal to a comma y. If and only if x is equal to a and y is equal to b. X comma y is equal to a comma b. If and only if x is equal to a and y is equal to b. Okay, na? So in general, a comma b is not equal to b comma a. Why? Because here a is in the first position, here is a is in the second position. Here b is in the second position, here b is in the first position. In general, both are not equal. When they are equal, first elements and second elements should be equal. So in this ordered pair also, if x comma a is x comma y is equal to a comma b, then x is equal to a and y is equal to b. Understand? So I hope that you understand this concept. After learning this, let us move to what is Cartesian product of two sets. Okay, na? Dear students, let us see the definition of Cartesian product of two sets. The Cartesian product of two sets. The Cartesian, the name itself Cartesian is given by a great mathematician, René Descartes. He is a French mathematician, René Descartes. On his name, the name Cartesian product is given. Okay, now, right. What is Cartesian product of two sets means? The definition is this. Let P and Q be two non-empty sets, any two non-empty sets. The set of all ordered pairs A comma B such that the first element A should belongs to P and the second element should belongs to Q is called the Cartesian product of the set P with the set Q. Okay, now it is denoted by P cross Q. We have to read it as a P cross Q. Don't read it as a P into Q. If these two are sets, they are not numbers. If they are numbers, you can say 2 into 3 like that. But they are sets. That's why we have to read it as a P cross Q. Okay. Let us give me one example, then you can easily understand what is this Cartesian product of two sets. Let the set P contains the elements 1, 2, 3 and set Q contains the elements A, B. Then their Cartesian product P and Q denoted by P cross Q is given by the set of all possible ordered pairs from P to Q. So here what is the first ordered pair, possible ordered pair? 1, A, next 1, B, next 2, A, next 2, B. Same as if you want to find out the Q cross P, what are the elements belongs to Q? A, B. What are the elements belongs to P? 1, 2, 3. So what is their Cartesian product? A, 1, A, 2, A, 3. B, 1, B, 2, B, 3. Okay now? Right. So this is the Cartesian product of two sets. But I am saying here, sir, P and Q are two non-empty sets, I am saying. Okay. If they are empty sets, what happens? What are the properties of Cartesian product of two sets? Let me explain. Okay now? Dear students, let us see the properties of Cartesian product. In general, A cross B is not equal to B cross A. Why? Because clearly in A cross B, the set of in the ordered pairs, all the first elements belongs to A, but whereas in B cross A, the set all the elements, first elements belongs to B. Then only we can say that A cross B is not equal to B cross A. If at all, if they are equal, that is A cross B is equal to B cross A, it is possible if and only if when A is equal to B. Okay now. Next one is if either A is equal to null set or B is equal to null set, then A cross B is equal to null set. That means out of these two sets, A and B, if any one of the set is null set, then A cross B is null set. That means, what is that from? A cross null set is equal to null set and null set cross B is equal to null set. Any one of this null set. If both are null sets are there, empty sets are there, their cross product is also an empty set. Understand? So these are the properties of Cartesian product of any two sets. Okay now? So I hope that you understand this concept. So let us go for next concept. Dear students, let us see the number of elements in a Cartesian product. So here A and B are two sets. Let us A contains P number of elements and B contains Q number of elements. Then their cross product A cross B and B cross A contains P into Q number of elements. Okay now. So the proof of this is also a very easy thing, generally anybody can say. So here there are two sets are there, A and B. A contains P number of elements, that means 1, 2, 3, so on P. Q contains B contains Q number of elements, 1, 2, 3, so on Q. So the number of ordered pairs A which belongs to A cross B, that means how many you will get? 1, 1, 1, 2, 1, 3, 1, Q. That means 1 is written how many times? Q times. 2, 1, 2, 2, 2, 3. That means the element is repeated how many times? Q times. P, 1, P, 2. Like that P is repeated how many times? Q times. That means 1 is repeated Q times, 2 is repeated 3 times, Q is again P is also repeated Q times. Altogether, how many ordered pairs you will get? Ordered pair starting with 1, how many you will get? Q. Ordered pair starting first element 2, how many you will get? Q numbers you will get. Ordered pairs starting with the first element P, how many you will get? Q will get. So on the whole, how many you will get? P into Q. That's all. That is the proof of this statement. Okay, very easy. Just like A cross B and B cross C, here the number ordered pairs may be different, but their count is same, P into Q. Same we can apply logically from B to A, we can apply same logic applies here. And the second one is a very important, it was given in some competitive examinations, that is if A and B contains M elements common m elements comma, then A cross B and B cross A contains m square elements common. Let me give an example here. A contains the elements 1, 2, 3, B contains the elements 2, 3, 4, 5. See here 2, 3, 2, 3. Both are common. A cross B, according to this formula, how many elements it can contain? This is a 3, it is 4. 3 4s are 12 ordered pairs. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 ordered pairs we got. Like that, B cross A also we got 12 ordered pairs. If you observe here, 2, 2 is common for both the sets. 2, 3, 2, 3, 3, 2, 3, 2, 3, 3, 3, 3. That means A and B contains 2 elements common, whereas A cross B and B cross A contains 4 elements common. That is, what are they? 1, 2, 3, 4. 1, 2, 3, 4. 4 elements common. So that is a very, very important point to what you have to remember. That means A and B contains m elements common. Then A cross B and B cross A contains m square elements common. Okay, na? I hope that you understand this concept. Let us go for next concept. Dear students, let us see the definition of relation. So in our day-to-day life also, we will maintain so many types of relations. That is, Rama is a brother of Lakshmana, and Sita is wife of Rama, and again Amitabh Bachchan is the father of Abhishek Bachchan. Like that, different relations we will see in our day-to-day life. In geometry also, we will come across so many type of relation between the two lines, two triangles, any two things. For example, L is parallel to M. Yes, it is a relation, is parallel to is a relation between L and M. Triangle ABC is similar to triangle PQR. Here similar is the relation between A and B. This PABC and PQR. Like that, number is also, in numbers also we will maintain some relations. What is that? 2 is a factor of 4. 2 is a factor of 4. 4 is a multiple of 2. Understand? Plus or minus 3 is square root of 9. Plus or minus 3 is the square root. What is this? Parallel, similar, is a factor, is a square root of, is a square. All those terms indicates, gives the relation between two items, between two items, those relations. But according to the mathematical definition of relation is this: let A and B be two non-empty sets. There must be two non-empty sets. Then any subset of A cross B, already we know how to write down A cross B. Any subset of A cross B is a relation from A to B. So to make you understand clearly, so I am taking here two sets. Let us set AB 1, 2, 3 and set BB 3, 4. As you know the Cartesian product, in that Cartesian product, how many elements will be there? Here 3 elements, here 2 elements, 3 2s are 6 elements you will get. From that 6 elements, take some elements outside. Let us take 1, 3. Yes, 1, 3 belongs to A cross B. Yes, it belongs to S. This is a relation. This is a relation. And I have taken 2 ordered pairs. Yes, it is a relation. I have taken 3 ordered pairs. I have taken all the 6 ordered pairs. Whatever may be that 2 ordered pairs. Whatever may be that in A cross B, you will get A cross B. You will get how many ordered pairs? 3 2s are 6 ordered pairs you will get. From that 6, you take the ordered pairs, some ordered pairs outside. That is called relation. So from this we can say that simply a relation is a subset of some Cartesian product. Relation is a subset of some Cartesian product. Some Cartesian product. Relation is a subset of some Cartesian product. Take some subsets from that Cartesian product, then we get a relations. Understand this? Now the question is, how many relations we can write down? So on infinite number of relations we can write down? No. So we write some finite. If A is a finite set and B is also a finite set, then we can write it only a finite number of relations. How many number of relations that we are we can write down, that we are going to see now. Okay now? Dear students, let us see that how many relations we can write from A to B or B to A. Let us say that A contains a P number of elements and B contains a Q number of elements. Then we know that N of A cross B contains P times Q, P into Q number of elements. Then the number of relations from A to B is 2 to the power of PQ. So this can easily say, but just in the number system we say. In the set theory I explained that if N of A contains P elements, number of subsets of A is equal to 2 to the power of P, 2 to the power of N. If N of A contains P elements, the number of subsets is 2 to the power of N, 2 to the power of P, 2 to the power of the number of elements present in A. Here also A cross B contains how many elements are there? Ordered pairs. A cross B contains how many ordered pairs here came? PQ ordered pairs. A cross B. Now what I told, so relation is nothing but subsets. Take some subsets from this. 1 ordered pair subsets, again 2 ordered pairs subsets, 3 ordered pairs subsets. That means we are taking some sets from the original Cartesian product. That means the set A cross B contains how many elements? PQ elements. Then how many relations we get? How many subsets we are getting? 2 to the power of P. Otherwise 2 to the power, if it is an M contains N elements. So what are the number of subsets? 2 to the power of N. Here also number of relations 2 to the power of PQ. Okay. So that means these many number of relations we can get from either A to B or B to A. Okay now, that's all. So this is a very easy concept, and our proof is also very easily understandable. The thing is that you have to remember that if a set contains N elements, then the number of subsets are 2 to the power of N. For that also I explained the proof for this. Okay now, I hope that you understand this concept. Dear students, now I am going to explain what is a domain, codomain and range of a relation. Let us take two non-empty set. Is the set A contains the elements 1, 2, 3 and the set B contains the element 3, 4. Then A cross B is given by 1, 3, 1, 4, 2, 3, 2, 4, 3, 3, 3, 4, that we know that. So here 2 elements, here 3 elements, 2 3s are 6 elements. Now I am taking a relation. What is a relation? Means I have taken some ordered pairs 1, 3, 1, 4, 2, 3, 3, out of 6 I have taken 4. So this is called a relation from A to B. It is a relation from A to B. Now let me explain what is a domain, codomain, range of a relation. So here domain of a relation, domain of the relation A cross B is A. The set of all the elements which belongs to A. That means 1, 2, 3. What is codomain? What is the codomain of A cross B? Is the set of all the elements which belongs to B. What are the codomain of A cross B? The set of all the elements belongs to B. Understand? What is the range means? The set of all the second elements. What are the second elements? 3, 4. What are the second elements here? 3, 4, 3, 4. That means 3, 4. That is the range of the relation R. So domain of the Cartesian product will be there, codomain of the Cartesian product, and the range of the relation. Range of the relation means what? The set of all the second elements of every ordered pair. Every ordered pair you have to take the second elements. That is called range of the relation. Understand? So that means all the first element, this is a domain, this is a codomain. After writing the Cartesian product, if you take some elements, from that you will get a relation. In that relation, the set of all the second elements belongs to range. Understand? From this, what can you say? The very important property, range is subset or equal to codomain. Understand? And so codomain means second elements. Range means we are also taking from second elements only. So that is range is subset are equal to codomain. Okay, so domain means first set, codomain means second set, range means in a relation. After writing a relation, so take all the elements from that is called range. Okay, now that is the range of the elements. So I hope that you understand this concept. So let us see the next concept. Dear students, now I am going to explain what is inverse relation. The name itself saying inverse relation. Inverse means opposite. Let A and B be two sets and R be a relation from A to B. Then the inverse of R denoted by R inverse, you have to read it as R inverse, is a relation defined by R inverse is equal to B comma A such that A comma B belongs to R. If an ordered pair A comma B belongs to R, then B comma A will lies in R inverse. Understand? If B comma A belongs to R, then A comma B belongs to R inverse. Understand? Very simple example. If R is 1 comma 2, 1 comma 3, 2 comma 4, 3 comma 4, 7 comma 8, then its R inverse is nothing but just to reverse the first element and second element. That's all. 1 comma 2, 2 comma 1, 1 comma 3, 3 comma 1, 2 comma 4, 4 comma 2, 3 comma 5, 5 comma 3. 7 comma 8, 8 comma 7. That's all. That gives the R inverse. But don't think R inverse means 1 by R. It is meaningless. It is a meaningless. But for number system it is okay. 2 power minus 1 means 1 by 2. 3 power minus 1 means 1 by 3. For numbers it is okay. For it is just a notation. This R inverse is a notation. That's all, which indicates that all the elements are reversed. That's all. Here from this anybody can clearly say what is the domain of R? 1, 2, 3, 7, all the first elements. This is called domain. All the second elements is called range. Just now I explained. What is the domain? 1, 2, 3, 7. What is the range of R? 2, 3, 4, 5, 8. If you observe here, what is the domain of R inverse? 2, 3, 4, 5, 8. What is the range of R inverse? 1, 2, 3, 7. That means reverse. The domain of R is equal to range of R inverse and the range of R is equal to domain of R inverse. So very, very easy concept. Anybody can understand this concept. Okay. So dear students, I hope that you enjoyed today's class. Today I explained what is ordered pair, what is a Cartesian product of two sets, and what is a relation, what is a domain and codomain of a relation, their properties, and inverse relation, and their domain and codomains of inverse relations. Everything I explained. So basing on this, some very, very interesting problems are there. So those problems I will explain tomorrow. So don't miss the tomorrow's class. Okay. I hope that you enjoyed today's class. Let us meet tomorrow.